In this video, we're going to talk about the tangent line problem. The tangent line problem is a problem that is related to one of the fundamental parts of calculus, and that is the idea of the derivative. So first off, let's take a look at what exactly is a tangent line. It's a little bit complicated to express the definition in an easy manner, but here we go. A tangent line is to a curve is a line that intersects the curve at a single point in some open interval. Okay, so that's part one of the definition. Let's just take a look at Desmos right here. And on Desmos, you can see here I've graphed a tangent line out, right? And so this line just kind of skims in and hits the graph right here. And let's just say these green lines are the open interval that we're talking about right here. So between these two green lines, right, the graph just intersects the curve in one spot right here. That doesn't necessarily mean the line doesn't intersect the curve in other spots, right? Like if I zoom out a little bit, I get this intersection point over here. So we're not really worried about that part right there, but in some small space right in here, the tangent line just comes and intersects the point. So right here you can see the tangent line just intersecting right there. And then the second half says if that line is rotated around the original intersection point by any small amount, then the line will intersect the curve in 2 points in that open interval in the neighborhood. So for instance, if I start rotating that blue line there, you can see, oops, I rotated it too much. If I rotate it any little bit at all from where it was, it's going to intersect the curve in not only that spot, the original intersection spot, but we're going to get another intersection point right here. So, and that doesn't really depend on the open interval at all, no matter kind of how I get that. If I rotate this line any at all in either direction, just a little bit, I'll wind up getting another intersection point in there. Okay? So that's what it means to be a tangent line. It intersects the graph in only one spot locally, right? In some open interval or neighborhood. And if you move it slightly at all by rotating it, then it's not a tangent line anymore. It cuts through in more than one spot. So, okay, so that's the idea of a tangent line. We can take a look at a bunch of different tangent lines on this graph. If I just move this little slider right here, you can see a bunch of different ones. And so you can see the thing that they have in common is that just locally they intersect the graph in only one spot, and then if you move it by rotating it at all, you're going to get another intersection point. So here, if I rotate it that way or that way, any bit at all, really, I'm going to get another intersection point. So that's what a tangent line is. And then the problem that we want to look at, the tangent line problem itself, is this problem right here. So let f be a function that is continuous at some number a. So we'll have the graph of the function here, and here's a on the x-axis right here. Since f is continuous at a, I know that there's a point on the graph at a, and that point would be a comma f of a, directly above a or below. At that point, what we want to know is, hey, what is the slope of the tangent line there? How can we figure out what that is? It turns out that that's a fairly difficult little thing to do because if you think back to, say, college algebra type problem where you're finding the slope of a line, you had 2 points, right, on the line. And if you have 2 points on the line, you could just use the college algebra slope form to figure out what the slope of the line is. But the issue is that we only have 1 point on the line, and that's that common point, the intersection point of the tangent line and the curve. So we don't have 2 points to use the college algebra slope formula. So that's going to be an issue, and that issue was eventually worked around. And in the next video, that's what we're going to talk about, the solution to the tangent line problem.